Okay.
Right,
Okay,
that is
I
looking
can.
good. So welcome
Okay.
everyone to a Neuroccino on this Monday morning, 9:30. I think we have one more Neuroccino left before the summer break. So without further ado, Alita, if you want to take it away.
Yeah, hi everyone. I am sharing the DOI in the chat so you can. Okay. Um, one moment. Okay, can you see my screen? Yes,
Yes, we
okay.
can. If you can zoom
So,
in a little bit so it's full screen.
yes, it's okay like
Perfect.
this.
Yes. Thank
Okay,
you.
perfect. Okay, hi everyone. So for today's Neuroccino, I've decided to present this paper by Globig and colleagues from 2023 that is called The Path of Dishonesty, Identification of Mental Processes with Electrical Neuroimaging. So just have a brief look to the literature before presenting the whole work. One of the main points, one of the most important points in the context of lie detection is one of the recurrent finding also in the context of lie detection is that lying takes longer than truth telling. It's a concept that has been developed by Zuckerman and colleagues in 1981 in his theoretical framework, that is the cognitive load approach to lie, in which lie is the formulation of the lie is described as a cognitive process requiring a higher cognitive load that is more time consuming and is more demanding than the mere automatism of the truth. Over the years, different and several authors have tried to understand which is the optimal level of cognitive load in order to better discriminate between a liar and a truth teller. But I think that as far as I know, very few studies have tried to understand which are the mental processes underlying the formulation of a lie. And in this work, the authors have tried to understand these mental processes. At first, they have tried to provide two possible explanations. First of all, they have tried to answer the question of why lying takes longer than truth telling by saying that maybe there are in the mental processes an additional mental process just present in the lying and not in the truth telling condition. But another thing that they have provided is that a second and non-mutually exclusive possibility is that maybe during lying and truth telling condition there are the same mental processes, but in the lying condition where one or multiple processes could necessitate more time. So these are the initial explanation that the authors have provided. But in order to understand better and to respond in a more precise way to this question, they decided to use an experimental task mimicking a real world scenario that I will show you in a bit. And during this experimental task, also using a continuous EEG recording and microstate analysis. Okay, so let's have a look to the methods. First of all, they collected 150 participants. Just a quick comment about the sample. It's not so bad, but I think that that is not very well balanced between female and male. As we can see here, there is a 2-to-1 ratio between female and male, and also the average age is just 21 years. With the education level that is not explicitly tell in the work, but I suppose that seeing that all the participants are recruited from the University of Bern, they have all a high education level. So I think that in future study maybe could be interesting to replicate this study with a more heterogeneous sample. But after this, the experimental task that I was citing before is this dishonesty task, namely the temptation to lie game, a very catchy name. That is a computerized two-player game that is, as I was saying before, mimicking a real world scenario in which the person could decide between acting dishonest or honest. To understand better the experimental task, I don't know if you can see it clearly. It organized like this. So the first screen, there are two cards that are presented. One card is the winning card, that is the Ace of Hearts, worth 9 Swiss francs. And on the other end, we have the Ace of Spades, that is the losing card, worth 0 francs. After the presentation of the cards that are in the first place hidden with the hidden content, there is the recipient's choice. So the recipient is the computerized part, while on the other end we have the real person, the real participants, that is the agent. So first of all, we have the recipient's choice, that is the recipient that is blindly assigning one of the card to himself and the other randomly to the participant, so to the agent. After this, two conditions could happen. We can have the unfavorable trial in which the agent, so the real participant, is getting the Ace of Spades. On the other hand, we have the favorable condition in which the participant is getting the Ace of Hearts, so the winning card. What happens here? So the agent's choice, the agent, that is this one wearing the electrodes, in the unfavorable condition, so after getting the losing card, can decide between these two answers, so between the self-serving lie and the other serving truth. In the self-serving lie, the agent's choice is to swap the cards, so decided to keeping the winning card by lying and giving up the losing card. In the other serving truth, he decided to losing by keeping the losing card. In the other condition, that is the favorable one, in which he has got at the beginning the winning card, he can decide between the other serving lie, in which he can, in a very generous way, decide to giving up the winning card, and in the self-serving truth, he can decide to winning by keeping the winning card. Each trial ends with a feedback, the third options that you can see that you can see down here. So this is the main description of the experimental task that I've been using in this work. So now let's have a look to the analysis that have been done by the authors. So first of all, since that the main goal of this study was to understand the difference between the self-serving truth and the self-serving lie, they decided to keep just these two conditions, not these two in the center. Okay, so after this first selection about the behavioral data, they calculated the mean response and the frequency of occurrence for the trial in which they told the truth to win, so the truth condition, and separately for the trials in which they lied to win, so the lie condition. After this, as I was saying before, they also have recorded using continuous EEG recording the brain activity during all the experimental tasks. And so in order to compare the neural responses between the truth and the lie condition for all the participants, they have computed two types of evoked response potential. So the first type is the stimulus locked segmentation, that is the one time locked to the card presentation, so the presentation of the stimulus. The other one was the response locked segmentation, so the ERP that is time locked to the participant's decision. After this separation into segmentation, they have averaged into 4-gram mean ERPs, each individual ERPs. So they have obtained two ERP, 2 Grand-Me ERP for the stimulus lock condition, so one for the truth and one for the lie, and other 2 for the response locked condition, so one for the truth and one for the lie. After this, they have realized that while analyzing the behavioral data, they have analyzed that there was a substantial inter-individual variability in time responses. So in order to don't have this main variability also in the brain, in the brain activation and brain activity, they have decided to combine the 2 segmentation in this way. They decided to combine 2 time window, the first one of the stimulus locked segmentation, the second one of the response locked segmentation, in order to not have an inaccurate conclusion for the later responses, for the later components of the brain activity. To do so, they use the global field power. That is a measure that has been used to determine the most reliable time window for describing each segmentation for the response locked and also for the stimulus locked. By using the values of the GFP, so high GFP that indicates reliable activity and low GFP that reflects, on the other hand, variability and noise, they managed to find these crossover points by using the GFP in order to separate in a non-arbitrary way the 2 segmentations. So in order to have this more accurate time window in brain activity. After this, they have done also the microstate analysis, as I was saying before, in order to identify recurring patterns in brain activity over time. So these phases of the brain activity across participants that are stable and recurring across participants, as I was saying. In order to do so, they has been used this clustering analysis, replicating both on the grand mean stimulus locked ERPs and both on the grand mean response locked ERPs. After having found the clusters, that spoiler, they have found 7 clusters across all the participants. They also have applied the topographical fitting procedures in order to understand also the latency of each microstate. So as we can see here in this table, the onset and the offset of each microstate in milliseconds. Last analysis that they have been applied was the source localization in order to finally understand also the intracerebral sources for each specific microstate. So in order to understand each microstates, where each microstates originated. Okay, let's have a look to the results. First of all, the first point was to understand and to have the confirmation if actually lying takes longer than truth-telling, and they have found this confirmation also in this study, finding that participants took significantly longer to lie than to tell the truth. Even if it's a confirmation from previous studies, I think that it's very interesting since, as far as I know, very often in previous study, the sample was split in 2. So we have the liar that can act just as a liar and the truth teller that can just act as a truth teller. In this paradigm, the interesting part, in my opinion, was that the real participants could face both the honest and the dishonest trials. So finding that also here in a paradigm like this, there was a significant difference in response time, I think that it's interesting. After this, as I was saying before, the main question was this one. So why does lying take longer than truth-telling? The answer to this question by using, as I was saying, the GFP, so this global field power, by using it, they found this intersection point. So the intersection point that was dividing the first segmentation, from the stimulus locked and the second one from the response locked. by finding that in the truth condition, this intersection point corresponds to the 478 milliseconds after the stimulus onset. While on the other hand, for the lie condition, they have found that this intersection point corresponds to 538 milliseconds. So also in the brain activity, they have been found a higher latency in the line condition and not presence in the truth-telling one. Then, as I was saying before, with the clustering analysis, they have found these 7 clusters. So seven most dominant topographies across all participants. They have found that 5 clusters was based on stimulus-locked ERPs, while the other 2 were based on response-locked ERPs. Fitting these clusters using the spatial correlation, they have found this very interesting thing. Okay, this very interesting result that I will show you with this image. So they have found that the upper portion is the truth-telling condition, the lower portion is the line condition. They have found that in the truth-telling condition there emerge 6 microstates that are all the colored part. Okay, so 6 microstates, so 6 mental processes underlying the truth-telling condition. While, as you can see here in the lower portion, they have found that there were 6 microstates. So there were an additional microstate not present in the first one, in the truth-telling one. So let's focus on these 2 in the center, since are the only 2 that differentiate between the 2 conditions. What they found also using the source localization is that the first microstate that is present in both seems to have a higher activation in the supplementary motor area, as you can see here. And they found also that in the truth-telling condition is longer than in the lying condition. They found this result at the beginning a little bit counterintuitive, but they explained this part by saying that maybe in the lying condition, since that this microstate is related to the supplementary motor area, so maybe to the preparation and the selection of the motor response, maybe this lower latency in the line condition could be related to a suppression of the selection of the motor response, followed by the 5th microstate that is present only in the line condition, that as you can see here, by using the source localization, have been found to be more related to an activation in the orbitofrontal cortex and in the dorsolateral prefrontal cortex. I'm sorry. Probably indicating that during this 5th microstate presence only in the line condition, there is this attempt from during the formulation of LI to inhibit the motor response, the previous motor response, to inhibit also the true response, and to by using the orbitofrontal cortex to that is known also as the reward and evaluation system, to understand which could be the best choice in order to gain and to win in that specific trial. Okay, the other activation, as you can see here, are explained here, but they are also better explained in the supplementary materials, not in the main text. So what did I found is that by analyzing the 2 mental processes, the 2 conditions with their specific mental processes, it seems actually that the response for the 4th question, so why does lying takes longer than truth-telling, is that actually there is an additional mental processes is a process present just in the lying condition and not in the truth-telling one, that maybe is activated just because there is an inhibition of the truth response and an activation of also an higher cognitive load to face the lying response, the lying formulation. I think that I've said everything. I'm not sure. There are a lot of other things to say, but maybe it's better if I stop. Thank you very much.
Lovely. Thank you so much. There was already a couple of questions in the chat. So I happily give the floor to whoever wants to go first. There we go. Chris, take it away.
Hi, thank you. I don't know if my mic is okay. Thank you for the presentation. Just one question about the experiment.
Yeah.
It seems that it's missed. Well, to me, they would need to do some control tasks because I guess that a lot of other things, other cognitive tasks can cause a delay in a response.
Yeah.
I don't know, like thinking about the answer, if the answer is a bit complex or if it's not a yes or no, or like do I lie or not answer. So how would we differentiate these answers, these other cognitive activities from a lie? Because of course we don't want people to consider that study to be like, oh look, that's how we detect a lie, but
Yeah, totally.
actually, yeah. So how do they talk about that, and do you have an opinion on that?
No, no, they haven't talked about this part, but I think that it's an issue for a lot of this study in the lie detection context, since that the main theory, as I was saying before, is this cognitive load approach to lie. So I think that your opinion is very interesting. It could be a very important part to develop in future studies in order to understand which is the part related to the cognitive load, the pure cognitive load, and which one can be selected and detected as a lie, the lying part. So they didn't, if I understood clearly, they didn't talk about this part, but I think that it's just because in the lie detection context is also often treated like this. So there is no such the proper distinction between the cognitive and maybe the pure lying part. I don't know if I answered you.
Yeah, but then they are not sure that they are actually detecting lies. They
Yeah,
might
no,
just
no,
be detecting
totally. No, no, no,
longer
no, totally.
processes.
I agree with you. I agree with you about this thing. I think that it's very important in the lie detection context to develop yeah, both to develop a paradigm that is not so, but I'm not sure if it's yeah, no, I just thinking, I'm sorry. It would be really important, as you was mentioning before, to have a control task. I have to think about which could be the task, but it could be really important to introduce something like this in future studies. I think the same, yeah.
Thank you. Lilith also has a question.
Yeah, thank you, Alicia, for presenting this paper. I was wondering, and also Valentina was in the chat also, I think thought the same question. So if this eventually is going to be used in forensic science, I was wondering if there are going to be, I mean, I think there should be some differences in the way people lie in prison or psychopaths, right? So
Yeah.
I was just curious if there are other studies that were explicitly trying to compare between these two types of groups, those who are didn't do anything wrong, and those who are in prison or psychopaths, if there are going to be differences in the way they lie, because eventually if this is going to be generalized to forensic field, then this might be not really generalizable
Reliable. Yeah. No, from I think that it's that this study stopped here, so I don't think that is a second part about this result as far as I know. But talking about this, I think that it would be really interesting to apply this paradigm also in some more forensic context. I think that the first part is, as always, trying to understand and to have a valid framework from the healthy controls. As I was saying before, also I think that there is a missing part in the healthy controls with a more heterogeneous sample, as I was saying, since we have just results on young and high educated samples. So I think that the first part would be to have a validated framework on the healthy participants. But after that, I totally agree with you about that. This part that would be really interesting and really useful, thinking about the later forensic applications, to have some data also in some forensic population, but also in some clinical populations too. For example, both in psychiatrics or neurological populations. I think that it would be really interesting. I don't know, for example, also talking about in psychiatric evaluation with the dark triad, so understand better the role of the formulation of the lie in narcissistic Machiavellism, psychopath, and so on. I think that would be really interesting. Or also in neurological condition, as we can see here, there is this involvement of the prefrontal cortex that, as Chris was saying before, it's probably due to this. It's not clear if it's just due to the cognitive load, or if if we can consider it as a marker of the lie. It's important to understand this. But as I was saying, maybe also trying to understand in neurological disorders this part with the involvement of prefrontal cortex and so on, with some patients with difficulty in inhibition or in control or in moral reasoning and so on. I think that, all this study would be, in my opinion, very, very interesting and very useful too.
Yeah, really interesting. Thank you.
Thank you, Lilith.
Hey, thank you very much.
Hey.
I have two very short questions, but it's mostly related to that figure you have now in the screen. So I can see that one of the main differences here is in the activation, or where they found some activity in the orbitofrontal cortex. I don't know if they discussed something about if this is just for making the decision of lying or not, more than some cognitive loads related to the act of lying. And also, I'm not sure if maybe I missed something in the experiment, but I don't know if the experiment actually, when you have the good cards and you can say the truth, that if maybe it's an easy decision just to say the truth because I have good cards, so I'm gonna win something, than so if they combine the truth of both cases, of course you don't need to think too much. If you have the good cards, of course you say the truth, right? I'm not sure if it's maybe
exactly. I think that it comes from this part of no thinking part in the truth-telling condition, comes from the previous studies in which the truth-telling condition is built and constructed as an symptomatic part. I don't know if it's clear. So I think that this is why the decision, it's very simple. So it's not so much related to an involvement of cognitive load and so on. I forgot your first question. I'm so sorry.
I just ask about this difference they see
Okay.
activity, I guess, or in the orbitofrontal cortex that is very, or its activity has been very related to the decision making. So maybe it's just
Yeah.
it's more difficult to, or take more time to decide I'm gonna lie, and that's what we see, just making a decision more than something specifically related to lie.
Okay.
That's my question.
Yeah, if I understood well, it's similar to Chris' question, but I'm not sure.
Yeah.
Maybe
It just is.
okay, okay.
Yeah.
Okay,
If they
okay.
mention something,
No, yeah, as I was saying
yeah.
before, I think that one important thing in the lie detection context is this one, to introduce something that could better discriminate which is the cognitive part. Well, it's important also to know that lie, it's also a cognitive process. So it's important also to understand this. It's a connubium of social and cognitive, very simplifying it, but it's a connubium of social and cognitive processes. So it's important maybe to understand I don't know how right now, but it's important to understand the difference between maybe this part and as Lilith was asking before, maybe also reapplying this paradigm also in not just in healthy control, but also in some clinical, in some pathological populations, for example. I don't know. Yeah, but very important question, very important point for this context, this research field.
Thank you.
Li Ting, quick final question.
I would be quick. So I just have a comment. Like I was curious. So the question is that we don't know if psychopaths would be maybe like shorter time to lie. And also I was thinking, how do people how do some people, they are telling a lie, but they probably don't know they are telling a lie. They probably really trust in their lie, and how does that also will manifest it in reaction time or in this kind of study?
I don't think that I totally get your question. What do you mean? Sorry, I don't totally get it.
I mean, I was just thinking about like politicians, they lie all the time, but
A politician. Sorry, I didn't. Okay. Yeah.
yeah, but they probably don't know they are lying. They just saying, and does
Okay.
that
Okay.
so how
No, so
does,
the question, okay.
yeah, no, I was just a comment like
Okay, sorry. Okay.
like,
Okay. Yeah, totally. Yeah, but for
because
all the works I read in the lie detection context, a lot of work started by mentioning the politicians' acts and so on. So it would be really interesting to also, maybe it's not possible, of course, but also to have some data about this kind of population, this part of healthy controls. That is, yeah, it would be really interesting. Yeah.
yeah, and I'm just curious, maybe is this a paradigm? Because I'm not sure, but as I read this kind of study, there always are moments of for participant already feel like, okay, there's a two situation. One is I need to tell a lie, and one I need to tell the truth.
Yes.
But then if there's a kind of paradigm is that you don't know whether you are telling the truth or you are telling a lie, but actually you are telling a lie or something.
Yeah, would be really interesting. I don't know experimentally how could you control the the condition in which each participant is yeah, could be really interesting, but I also for this I need to think about Well, the best representation for a paradigm like this. Usually, as I was saying before, the paradigm is with the splitting of the participants in two, with liar in a sample in a group, and the truth-telling in the other one. This one was, I think, interesting because you can decide what to do. So it's maybe a real world scenario, as I was saying before, because it's not mandatory to lie or to tell the truth just because you are in one of the two conditions. So it could be really interesting not to know what you're doing, not to know, but I don't know what can be done, but it could be interesting. Yeah, thank you.
Thank you.
There's always more work to be done. It's great. Thank you so much.
Exactly.
Thanks for presenting the paper. We're going to have one more Neuroccino next Monday by Pedro, and then it's time for the summer break. So until then, have an exciting week in science, and see you next Monday and also on Wednesday for a CNS talk this week. Bye.